And sorry, before, and if I want to share my screen, can I do that or no?
Yeah, so I'll stop sharing my screen and then I'll
Oh,
mute
okay.
myself and then you can go ahead and share your screen.
Perfect. Fantastic. Thank you.
Okay, so we'll wait about a minute or so before we get started.
Yeah, yeah, absolutely. I'm trying to do,
Okay. Great to know that that there's someone who's excited about today's topic. Someone said they were excited and been waiting 3 weeks for today's webinar on the chat.
wow, so kind. Hopefully it meets the expectation.
Okay. Okay, I think we'll get started today. All right. So hello, everyone, and thank you for joining us this Saturday for our webinar on how AI and decentralization coexist to push forward to the next revolution. Today we have Farshad Kiri leading us in this topic. Farshad has over 12 years of experience as a data scientist and AI expert. He worked as a researcher at UCLA Neurology Department for 3 years and then worked in several startups, a hedge fund, and an incubator. He holds 2 masters and a PhD with a minor in mathematics. He works at 55 Foundry as a head of AI and data science, a company with a main focus in decentralization technology. Right. But before we go into the topic today, I'm going to talk about a little bit about what Ideas is and what we stand for. So, right. So Ideas stands for International Data Engineering and Science Association, and we are a nonprofit organization located in California. Our mission is to bridge the gap between academia and industry, and we do that by providing robust resources and connecting real-world expertise together from business leaders, professionals, and promising students. We empower and nurture community growth by offering online resources, conferences, latest industry trends, and data-related job opportunities. We began our journey in 2016, and we have organized various events around the nation, from conferences to blockchain hackathons covering topics like data science, machine learning, and we try to bring in leaders from the industry and academia together to guide and empower the next generation of leaders in these areas. So here are a couple of our events that we host: our 2016 SoCal conference at USC, our 2018 New York Blockchain Leadership Connect, our 2018 Chicago Blockchain Leadership as well, and then our 2017 SoCal conference at the Pasadena Convention Center. We do try to host all of our events around the nation to make sure that we provide access to all of our students, everyone who is a part of this organization. And here is our 2018 SoCal conference at the Los Angeles Convention Center. We do have our 2019 conference coming up this October. So if anyone is interested, you can find more information on our website. Here's just more pictures of our events. And then we do host various meetups, at various universities and around the nation, and we do try to make sure that we are reaching our goal to bridge that gap between academia and industry. And here's just a list of the universities that we have hosted our meetups. And if you are interested in learning more information about us, you are more than welcome to check out our website, our LinkedIn, our social media outlets, and also to send us an email. All right. And without further ado, now we move on to the main event of our hour. Farshad and Kiri, thank you for joining us again, and the floor is all yours.
Thank you. Thank you very much, Jasmine, for a very kind introduction. And thank you, everybody, for attending this meeting. Do you guys hear my voice clear, or is it good? Okay, so let me share my screen. This. Okay. So yeah, my name is Farshad. I'm working in 55 Foundry, and our company is focused on decentralization. And my role is to find and investigate how AI and decentralization can work together. So I want to share some of the things we have done, and I think there's an amazing opportunity here, and I like to as we talk about this today here, I think the whole talk shouldn't be more than 15-20 minutes. And then I'd like to hear you guys' thoughts on these, and that will be fantastic. So I will start with what is AI, and then I will continue with what is decentralization. What do I mean by decentralization? And then after going through these two, then we're going to say how these two can actually work together. So yeah. One of the most common definitions that I think everybody agrees on, that I think it's from Minsk, that says AI is any task that performed by a program or a machine, that if a human wants to do that, it requires some level of intelligence. And it could be some planning, learning, reasoning, or problem solving, or knowledge representation, perception, motion manipulation, or social intelligence. There's several others they can fit here. I didn't put it here. But what is in common in all AI models and platforms is learning. So learning by example is actually something that I don't know of any AI algorithm that is not using that. And if I want to simplify it, is the way that, if you think of a toddler, if you try to teach a toddler what is a table, what is a chair, and first show him the top two pictures. So the thing that happens is the brain tries to find some common features between these objects to say, hey, this is a chair, this is a chair. Okay, if I show a toddler that this is a chair, it says, okay, so what is in common between these two? It says, okay, it has 4 legs. And then I show him the third object and say, this is not a chair. And it says, okay, so we have having 4 legs is not the only condition to have to be a chair. And let's assume there's another leg on the other side. And so, you should be able to actually sit on it. So you should be able to sit on it. It should support your back, and it has to have 4 legs. And then I show him another example. It says, okay, so it doesn't really have to have 4 seats. It could have less than 4 seats. So now, if I take that toddler to the outside and say, okay, now tell me which of these are chair and which of them are not. And so he look at the same first picture and says, okay, it has 4 legs. You can sit on it and it supports your back. It's a chair. This one is not a chair. This one is a chair. It's kind of look like this one. And this one is not a chair because it's not supporting your back. So that's what we call learning by example. And this part is the whole learning process that happens. And this part is the testing process. So what happened here, we trained a model on a training set, and then we tested it. So if you look at it, this child was correct 50%, and 50% it was incorrect, which is not really good because it was like, if I was dropping a coin, it was a 50% chance to. So, but that was like what used to happen in traditional machine learning. But then, if you guys go and like build these models, and I'm pretty sure many of you guys have talked to people about like what you do. Again, I assume that most people attending this conference are data scientists. So you see that the first question they ask you is, as these models see more data, are they going to get smarter? And that's what happens to the human brain. So when a human brain sees these things, and if a toddler says this is a chair, and I tell that toddler that it's not a chair, it's going to learn. It's going to continuously learn that this is not a chair. So that's next time, if I show this image or something similar to this, it's going to classify it correctly. And the same thing to the next one. So that has been named as continuous learning, and a lot of algorithms that we have been using traditionally, like 5-6 years ago, now by some adjustment, we can make them, readjust them and make them to work in a continuous setting. And there's actually a book here. I should have brought it out. I will try in the end of the talk to bring it up. So I saw that one of the books that was written on this, and I was really excited about this whole thing. Like some algorithms, like naive Bayes, can be easily adjusted and adapted to become actually to work in a continuous setting. As you see examples that they disagree with what you learn from your historical data, you can update them in that way. So, okay, now let's see what is machine learning. So machine learning, they say, so algorithms based on mathematical models which can extract patterns from data. And when we say data, we usually mean some historical data that you can't get access to it somehow through, your company, your websites, or the products that you're handling. That's you will be able to gather some of this data, and then you build a model on those. And then I'm just laying the intro on AI, so bear with me. So we have two very famous machine learning algorithms named supervised and unsupervised, and it's very clear. For some reason, these images are not shown very clear on this computer, but on my other computer they're very clear. So here we have given it some images. I don't know how much you can see. I can't see really clear here. It says this is a duck, this is a duck, this is another duck, this is another duck. This is a supervised learning algorithm. And then this goes as a prediction or classification that kind of decides that which of these is a duck and which one is not a duck. So, so in a supervised learning, you have to label your data, but in an unsupervised setting, you don't label your data. So you say, and you let the model make that decision that which of them are going to be grouped with each other. So in this case, it's going to group these three together, this one and this, this 1, 2, 3 together, this one separate, this one separate. It may decide based on the way the ears look like. This one has feathers, this one doesn't have feathers, and things like that. But on unsupervised learning, you actually leave it to the model. And the groups that you make, you don't have a label for them unless you have an expert in the field, like let's say a zoologist come and say, these are birds, this is a mouse, this is a bunny, and then you come up with their labels. And unsupervised learning are doing an amazing job, especially when you don't have any expertise or you think you want to challenge the current hypotheses that exist in the field. And you say, I want to look at it from a different aspect, so I don't want to have any misunderstanding or any use any bias that experts have towards this concept. So I'm going to start with unsupervised learning and see what the data is going to tell me. So another field of machine learning that you have heard a lot about is deep learning. So deep learning was initially was motivated or inspired by human nervous system, and human nervous system basically works on signals goes through neurons. If this level of signals goes higher than some threshold, the neurons is going to fire, and then it's going to trigger the other neurons, and then the signals is going to pass through. So the same idea was applied to mathematicals. Like these are like the neurons, and then if the entrance voltage or the entrance input goes higher than some levels, then it's going to fire, it's going to let the signal go through and goes to the next level. So then this last layer is as output layer, and these are as input layer. So yeah, as I said, so deep learning is actually a subfield of machine learning, and it has two advantages. Even though the deep learning, they call it like artificial neural network in the beginning, but because it was, as I said, it was built based on human brain and the way that human nervous system works. But because the computers weren't fast enough, they weren't really being used. And if you, again, I apologize for this, I don't know, because maybe I transfer these slides from one computer to another computer, it's not very clear here. This says performance, and this says amount of data. So in traditional machine learning algorithms, if your amount of data is go higher than some amount, the performance of the model doesn't increase. The performance stays the same, or somehow even it may decrease if you actually feed the extra data. It may cause some overfeed. But in deep learning models, as you enter more data, the performance of the models is going to increase. So, and that's why even though deep learning techniques were first came to existence in 1990, about 30 years ago, these people started using them more recently because we have a lot of data on internet and got access of this all terabytes and tons of data that we got through internet. So the other advantage that deep learning techniques had was, and another thing was computation power. They were very hard and to be trained, and computers were very slow back then. I remember Pentium 3, Pentium 4, very small artificial neural networks could take a couple of hours to be trained on small data sets. So nowadays, no, you can run it very fast. TensorFlow came to existence, and all those good stuff made these models very, very accessible and easy to be trained. Another advantage that, that deep learning techniques have over traditional machine learnings are they don't need feature extraction. You remember when I said human brain, when it wants to learn, it actually extracts some features of the objects that you show it and say, hey, you know, this is a chair, this is a chair. So it looks at them and says, okay, it has to have 4 legs. I should be able to sit on them, and it has to support my back. So these parts called feature extractions. And that's where a model extracts some features. Let's say we want to identify if this object is a car or not. First, we have to extract some features. Let's say it has tires, it has 4 tires, it has window glasses, and things like that. And then build a model on those features. And then, you know, the output will be, is it a car or it's not a car? But in a deep learning model, you don't do that. You just give the raw image to the model and let the model to figure it out which pixel should be more important or less important. So that makes the whole machine learning training process more amazingly simpler. But again, the tuning of these models is extremely tricky, and it's going to be, going to easily overfeed if you don't know how to tune them. So if I want to put all these together, it's going to be, so if you look at this artificial intelligence as a whole universe, then machine learning will be a subset of it, and deep learning will be a subset of machine learning. So, okay, we'll leave it here. Now let's go to the next topic. What is decentralization? So decentralization first was introduced by this French journalist in a French journal that name, and the name of that title, that article was This is Decentralization, in Maurice Bloch in 1863, about 150 years ago. So, and it means that the activities of an organization, especially those with regard to planning and decision-making, are distributed or delegated away from central authorities and to all the members that are part of that ecosystem. So that was the definition of decentralization. And the politicians, philosophers were trying to say that this is the best way to even run a government. So, but it eventually came to technology. some people think that it started by Bitcoin, but in 2008 when the blockchain technology started, but it was a little further back. So let's talk about centralized platform. Most platforms that you know nowadays, they are centralized platforms, like Google, like Facebook that you use. And the way that they work is like you have some app on your cell phone, or you use a web app through your laptop or desktop computer, and connect to a server that is located somewhere in Silicon Valley or somewhere in Southeast Asia, whatever is cheaper for them. And then you communicate with these, post your things on these, or send your emails through these. And but as I say these things, I'm not an expert in computer, and I'm not a software engineer, but I can see a flaw in the system. And the biggest flaw is, if anything happens to the server, all these guys are going to be impacted. So if a hacker hacks into the system, all these guys are going to be hurt. If this guy decides to upgrade or shut down the system, all these guys are the whole system is halting. And if I send a virus through one of these guys to this system, everybody is kind of damaged. So these are the biggest challenges that we've seen our centralized system. And we have seen all these things that I just said. We have seen it here and there. We've seen that LinkedIn or Yahoo emails were hacked. We've seen that Experian, like one of the supposedly most secure platforms for our financial data, has been hacked. I can't remember. I think it was 150 million people or 50 million people were their financial data were hacked, and it's out there. I assume it's the chance that any of us in that, if it's 150 million, is 50% my name is on it. So if you compare a decentralized platform with a centralized platform, you should not put all information in one single entity. And then a transaction, when I say transaction, I mean any kind of transaction, could be validated without a third party. I will explain this later on. Transparency means that all the transactions that happen on a decentralized platform, they are completely transparent, and you can see that where it came from, where it went, but you don't necessarily need to identify the identities of people who are involved in those transactions. Immutability is another thing, which means the data entered to the blockchain cannot be tampered. And the transactions are going through a hashing algorithm. They call it SHA. The one that Bitcoin is using is SHA 256. And it's basically a function that it puts, like you put it in front of all this text, it's going to pass you a 256-bit data. And if I change a comma or even a space in this text, the other 256-bit data that comes out of it is totally different. That's why they call it an avalanche effect. So a minor change is in the data is going to change the whole SHA output. So this way, even like, as I said, even space or a comma is going to alert the system that something huge has been changed here. So as I said, Bitcoin is not necessarily a blockchain technology, as the first one as Bitcoin, is not necessarily the first one. I don't know how many of you are young enough, or maybe even nowadays it exists, I don't know, that you have used BitTorrent to download a movie or a audio file. If you do, please don't say it. But the way that system is working is a peer-to-peer network, and it's a file sharing, so they call it torrenting. And so the way it works is everyone who is connected to this network, download that piece of information on their laptop or computer, and as long as they're connected, they are a host and they can download from other platforms. So if for any reason, let's say I am one of those guys, I decide to turn off my laptop or my computer, I come out of the network, but other people are there. And so if someone decides to download one of the files that I am sharing, because I'm not the only one who's sharing it, there are other nodes in the platform or other computers that are sharing the same file. So if anything happens to me, it doesn't affect others. If the file as is on my platform is corrupted, it's okay because there's 10,000 other people on the platform that their file is not damaged. And if I decide to intentionally damage some file or do censorship, anything, because others that exist, they're not damaged, my file is just gone. No one cares. So that's why I said like this whole decentralized platform existed much longer before that Bitcoin actually came to the existence. So Bitcoin came to the existence in 2008 when a paper came to published in 2008 under the name of a guy named Satoshi Nakamoto, if I pronounce his name correctly. And so people were thinking about having a digital currency, which, a money for a long time that is actually on internet. But the challenge was, like, if I have a $1 bill that is a file, like an image or a photo, I can just copy and paste it 10 times and make it $10, or copy and paste it 100 times and make it $100. So Satoshi in a paper suggested an algorithm to solve the problem for double spending, and he came up with some miracle. He didn't came up, that actually existed, miracle algorithm and some proof of stakes and proof of work to validate. Actually came up with proof of work to validate those transactions and verify those transactions. So the way it works, someone comes to this network, asks to request the transactions, and then that transaction will be broadcasted to this peer-to-peer network. Then these guys who are in the peer-to-peer network, they're going to validate their transactions, and they're going to validate the user status. When I say they validate the user status, let's say this transaction is, I want to sell a house. So they say, okay, let's see if this guy actually owned this place in the first place. So let's actually come up with some architecture. Let's say there's about, I don't know, 5 million houses in US, and each of them has a unique ID, and we put it on a distributed database. And they say, okay, this house with this unique ID in Manhattan Beach belongs to me. Now, my name is on it, and this unique ID is there, and I have a key to that. I have a certificate that matches me and says, hey, I am the right owner, because if you match these two keys together, it says, yes, he actually has this. And they give me that key, and I keep it somewhere safe on my USB drive. Now I come here and say, hey, I have this USB drive. I want to sell this to Jasmine. I say, hey, Jasmine, I have this house. She says, okay, show it to me. I put it on the platform. I said, I have this house. And then this peer-to-peer network is going to say, yes, he actually has it. And his key matches the key that we have on this database. And when we run some algorithms to validate these, that says, yes, he has it. And then as soon as they prove that it has it, now I can make the transactions to someone else and say, I want you to give me to someone else. And that transaction will be written as a permanent block into the blockchain. So no one I can't come back later on after I get the money from Jasmine and say, hey, now I want to change it. I want to take over the house that I sold. No, because that transactions was written into the blockchain, and its permanence is unchangeable. And if you look at it, it's kind of a database with timestamp. It says, I own it from this date up to 26th of July, 2019. From 26th of July, 2019, it's owned by someone else. Then if it wants to come back to me, then Jasmine, who owns the new key, has to allow it to happen. Otherwise, it can't happen. So the transaction gets complete. So I actually imply something else during this whole scenario, which is actually cannot be done currently through blockchain, through Bitcoin. It's something that I will come back to it, named as a smart contract. So I was talking about ways that people can actually verify or validate these transactions. So the one that Satoshi actually proposed in his paper was a proof of work. So the proof of work works based on this idea that it's a hard mathematical problem. It's costly and time consuming, and you have to run it on your computer or on your device. And as soon as you solve it, then you can validate or verify transactions. And it stop the double spending problem. So you can spend $1 two different times, or you can make a copy of those. So, and then after someone solve that problem and allow a block be written to a blockchain, then it's be rewarded by a token, which could be a Bitcoin. And that's what we call mining. So that's the rewards that the miners are going to get. However, there's a problem with that. I don't know, as I was explaining it, you most likely got the problem is, but I should tell you the details. So later on another version of blockchain technology named Ethereum, people came up with another way to prove these to validate these transactions, and they name it proof of stake. So proof of stakes works based on the number of tokens someone has, the tokens of that ecosystem. So let's say, because it was first proposed in Ethereum, is the number of ether. They call the tokens in Ethereum ether. The number of ether that you have, the more ether you have higher chance to actually be selected to validate the transactions. And after you validate those transactions, you get a transaction fee. They don't reward you. They say, okay, like let's say this transaction was 100 ether, we give you 1% or 0.01%. If the whole transaction was 1 ether, the reward is much lower, or the transaction fee is actually much lower. But so what was the difference between these two? So as you remember in proof of work, I said you have to solve a very hard, time-consuming mathematical problem. And in 2015, I think they said to create a one block to the Bitcoin blockchain, it costs the same electrical power that 1.57 American household consumes in one day. And then they said by 2020, the amount of electricity that you need to run Bitcoin blockchain is equal to the whole electricity that the country of Denmark is using. So that was why Ethereum community decided to come up with a proof of stakes instead of proof of work. And they said, if you use proof of stakes, if you are a forger, if you are a hacker, you need to own some coins in that system. So in somehow we can incentivize wrongdoings. And if you incentivize it, if you validate some transactions that is not actually valid, then later on we find out about it, we're going to come back after you and we get your tokens back. But in the proof of work, because you just run your computer, even if you cheat the system, they cannot come after you because you got your Bitcoin, you put it in your wallet and you're gone. So yeah, if I want to show it in two graphs, it actually this comes from BlockWeeks. I liked it. I decided not to reproduce it and just put it as it is. So in proof of work, to add a block to the blockchains, miners must compute or solve some problem. But in proof of stakes, they have to have just tokens. In proof of work, for a bad guy to take over the computing power of their computer or laptops or nodes that they are running the blockchain on should be stronger than 51% of the network. But in proof of stakes, if a bad guy exists, he should own 51% of all the tokens or cryptocurrency in the network. And finally, these guys are being rewarded after they finished proving and validate transactions. But these guys are just going to get a transactions fee and they're not going to be rewarded. And that transaction fee is part of the whole transactions. And so the guys who don't do the transactions are supposed to pay the fee. So you remember I mentioned smart contracts. So one amazing thing that the team from Ethereum did was creating not only a distributed database. So blockchain so far is a distributed database, has timestamps, and it's going to be on different computers and nodes. But one of the things they add on top of that, they allow you to run some codes on this decentralized platform. So going back to the example I said about Jasmine want to buy my house. Now, that whole buying should be a smart contract, which could be an escrow. So the escrow says, Farshad owns the house. Yes. Jasmine paid Farshad like this amount of money. Yes. Now the transaction is going to happen. So these two should happen, then the transaction is going to happen. So these smart contracts are unchangeable, unalterable codes that are being placed on a blockchain, and no one can change them unless the majority of the community of Ethereum for that platform decides to change those codes. So now I want to show you the same graph I showed you before with regard to decentralization. So if you look at decentralization as a whole universe, blockchain technology is a subset of it. And let's say Bitcoin, Ethereum, Definity. Definity is actually, I'd like to put Definity there, is a third generation. If we count Bitcoin the first, Ethereum the second, Definity is going to be the third generation, which allows the happening of new internet or a decentralized platform to host web apps or any application you want on internet. We're going to come back to this. Now, in our company, we are, my focus of research is this part. We actually call it Ex Machina, and it's the intersection between AI and decentralization. So data is the most important part in a data science field, in the AI field. And some of the challenges that data has is ownership, privacy, and trust. And this is where blockchain technology or decentralization can help. So I try to stay away from blockchain technology, and I prefer to use the word decentralization. And I will explain in the challenges what's the main reason. So in the decentralization platform, we have on the ownership, we want to find who owns the data. On the privacy, we want to know what data to be shared. And the trust, we want to know how is the data is being used, how the data is being used in that platform. So one of the platforms that we built is data integrity, and we address it for medical field. So I'm just going to tell you like how this could actually work together, but I'm not going to go through the architecture because it's kind of like IP. So the challenge is when someone has some data, it could be medical data, it could be employment data, that data, we could give a certificate key to that person that this is your data and you own this data. And so when he stored it on a decentralized platform, he is the only person who has access to it. However, we find there's a challenge, and the challenge is sometimes some of this data that come to the blockchain could be just garbage. And who is going to validate those? In many of these platforms, the validation happens by human. Just in a small platform and with a small number of users, that is valid. That is valid and that's doable. But in a big platform with a lot of users, and if you want to scale, that's really not doable, and that's not really acceptable. So sorry, one sec. So and also we can identify if this data is tampered or if is stolen. So that's the part that AI can handle and work in conjunction with decentralization to address these two issues. So as I said, one of the biggest terms in data science, we say garbage in, garbage out. So yes, blockchain is give us this free access to data that has been validated, the existence of it, but we don't know what is the content of the data or if the content is something valid. So this should happen with the AI models, and that could actually have a big impact there. So that's, as I said, decentralization clarifies the ownership, and AI determines the authenticity of the data. That's what we call a data integrity platform. One other use cases is federated learning. Federated learning have been around for a while now, and the main focus is ownership and privacy. So in some cases of machine learning, you cannot share the data because of some privacy concern or some regulatory impediments like HIPAA or GDPR. They won't let you. There are so many rules that won't allow you to share that data. And or sometimes it's not that's not the case. The data set is so huge that it's not easy to move it around, and it's not worthy. So the way that data scientists and AI experts try to solve this, they said, okay, I'm going to train the model on the local device, like it could be on your cell phone or on your computer. And then after it's been trained there, then the models have been trained on all these computers and cell phones, and then the output of them is going to go to a centralized platform. You combine them. It could be an ensembling techniques that you combine all these models, and then you take all these models to different platforms, and then the ensemble one pass it back to each of these. So now this device is going to take advantage of the models that exist on other platforms. So it's very straightforward, and I think even someone who's not an expert in the field can understand the architecture of such a platform. But also someone who works in a decentralized platform can understand that this is actually a great fit for this blockchain technology or decentralized platform. So this whole team can go on a decentralized platform. The whole compensation of, you brought in this data, you should be compensated that much for your data. In compared to someone like me who hasn't brought in any data, then I can buy your data or buy your model, not your data. And then all this whole thing can happen in an autonomous organization. Label visibility is another platform that is going to address the trust. What do I mean by label visibility? So you have all these devices, this cell phone, iPad, computers that you gather data from. You log into your Facebook account, and then at the same time that you are in your Facebook account, you're going to go search for furniture, and then Facebook finds out about that, and then they start recommending furnitures to you. So what happened? All this information went at the same time that you open your Facebook account, you open new pages and go do your furniture research, or you buy some shoes. All these go on a server, and this data is going to be stored on a server. Then what happened next is that data is going to be labeled. I'm going to give you some examples of labeling data. And then after the data is labeled, then the next step is these organizations or entities like Facebook, Google, or Yahoo, or LinkedIn, they're going to build some AI models around those labels. And they're going to recommend, they're going to make some recommendations to you. They say, hey, I should sell this guy this, or I should give a loan to this guy, or I should give some free Uber rides to this guy. And then this way I'm going to increase my profit, because this guy, they're going to get hooked, and then it's going to take more rides, or I'm going to give this offer to this user. So what happens is, from these two red spots, you as a user, you have no exposure. You don't know what happened. Me personally, as a user, I really don't care what happened in the server, and I really don't care what happens in AI models. I really don't care what techniques you're using for AI models, and I really don't care where you store my data. But what I care about is, how do you label me? So it turns out, let's say you're getting a loan from a bank. So if you make all your payment at the right time, and your loans go through, finishes, the bank, let's say, makes 20 cents on every dollar they lend you. Now, let's say the banks, you miss some payment. You forget. You miss 2-3 payments, you come back, make 2 more payments, and then you miss 2-3 payments, you come back, make payments. It has been seen, I have seen real data from real customers, that people sometimes make $3 on every dollar they borrowed. So now imagine this evil bank goes and tag that client as a good client, as a better client than a client that actually made all the payments in time. Now, let's say that bank has a fixed amount that they can lend. They have $10 million, they have $10 billion. They prioritize bad clients, I mean, I don't say bad clients, I say messy clients that they forget to make payments over the clients that they made all the payments on time because they said, okay, this guy, I'm not going to make any money on him. Why should I give him money? He's a good client, so he always make his payments on time. I make like 5 or 10 cents on every dollar I give him. But this guy, he's forgetful. He misses payments. He has a seasonal job. Sometimes he has money. Sometimes he doesn't have money. So every dollar I give him, I sometimes get $2 back, $2, $3 back. I love this guy. This is unethical. And if you find out that a bank is doing that, you most likely are not going to take your business there. But you don't know if your bank is doing that or not. That's what we call, we don't know what's the label. So that's what I mean with the label. Or let's see the approach that some platforms, some social platform took against fake news. I actually have a couple of articles on that. You can Google me with fake news and they will come back. You can see them. So if you say to the social platform, hey, I think this news that you're showing to me is fake, they will hide it for you. But you don't know if they will hide it for everybody. And most likely they won't, because those articles are clickbaits. And they love it because, hey, that actually, you click on that article and I made money out of marketing, so I'm going to show it to other people. Why should I actually hide that article from other people? But if you find out that that social platform wasn't hiding that article for everybody when you told them that this is a fake article, this is bull, this is BS, then you be concerned on using that platform. So that's what can be addressed through a decentralized platform. And finally, I thought it's not a bad idea to show you this one as another example. So, cryptography is a very interesting field. And the way that, let's say, Alice trying to communicate with Bob, they should have a key that both of them share that key. So Alice have a message, it's going to send through a channel to Bob. And because Bob has the same key as Alice, can decode that message and gets this. Now, let's say Eve is a attacker to the system. It tries to decode this without having K, which is the key, and find what was this message. Now, I saw an article that's very interesting. They use GAN, John's Adversarial Network, which is, some of you are, very great data scientists. I'm pretty sure that you know about GAN and you know how it tries to build the best classifier by using synthetic data that is very close to a real image. And it's actually mostly being used for image, but it's not the real image. So the same thing, they did it here. They tried to create the best version of attacker as Eve, and they tried to stop that attacker. And then they said, if we can block the best Eve, then we can stop every attacker. I'm going to show you the article in the end, so you can refer to it if you like. But I like to conclude this. Why I didn't call this blockchain? Because blockchain, it still has a lot of challenges. You cannot save a lot of data on a blockchain. It's very challenging. Even like Bitcoin, I remember like 2 years ago when I downloaded it one time, the whole transaction was a couple of gigabytes. I don't think it's more than several gigabytes now. You can't like put like MRI images on a blockchain. It's impossible. It doesn't worth it to put that much data on a distributed database. So you need to come up with the right architecture. You remember when I showed you label visibility? I said I don't care about the data. The data could be anywhere. It could be on a centralized server, as much as I care. But I want to know what is my label. So the label is not a huge data set. It's a small data set, and I can easily put it on a blockchain. So you have to come up with some tricky and intelligent way to build the architecture for this kind of platform. And then finally, that was why I brought up the name of Definity, because Definity is the whole message is we are creating the new internet, and it's Definity is actually a partner with our company. So the idea is we're going to create a platform that you can create your web apps or your websites on it. And this platform is not being controlled by anyone. There's no authority on it. It's not like Facebook can promote or block your product because you don't pay them or they don't like it or for any reason. So in a decentralized internet, no one owns it, and it's distributed all over, and no one is controlling it. And but now you will tell me, so if we have a Facebook that no one is controlling it and no one is owning it, why people should do that? I mean, who makes money out of it? Why should I help building such a thing? So that's why those tokens are created. So those tokens eventually, because they are necessity to do, like, let's say if you want to prove a transactions to go through, you need to do a proof of stake. Then if you are one of the first developers of that platform, you can get more tokens for yourself, and then later on you can sell those tokens, and this way you get paid for those tokens that you spend on this platform, and that kind of is gonna compensate you. So that's the idea of like why this kind of work. And then when the new internet is gonna come, which I don't see it far away, I think it's gonna impact the field of AI and data science hugely. Think about it, like most recommendation system that we build for marketing nowadays is like, okay, this guy bought this shirt, so most likely he's gonna buy this shirt. So let's push him to this shirt and let him buy this shirt. So now big companies, they own your data. They can manipulate your decisions. But in a decentralized platform, the ownership goes back to the user. So now when we decide that we design these or we architect these AI models, we're not going to say, hey, I should promote this guy to buy this, or I should manipulate this guy to buy this, but I should find what is the best for this guy, because he can decide what data he wants to share or what data he doesn't want to share. We have actually two other applications that I didn't put it there. One was pattern discovery through decentralization, which actually is very applicable to marketing. And we're going to say like how you can, based on the record of transactions, you can decide that what someone is the best for someone to buy based on what other people decided, not what I want to push you to, like to some content modeling or some item or user item modeling techniques. So that's why we think that the existence of new internet is going to highly impact the way that we are going to build in futures AI and data science models. So I think that will be it for me, and I'd like to actually show you a couple of these articles. This was one article that I saw yesterday. It's actually it's a very recent article. It's someone from Microsoft wrote it, and it's about democratizing AI. So you build a model, you put it on a blockchain, and some other people can improve on it and then be paid and something like that. I think this is great. This is an amazing idea, but I'd like to know how much doable it is based on the speed and the ability of the blockchain in the current world. This is the article. This is not actually the article. This is someone actually explaining how adversarial GAN is going to be used for cryptography. The real article is something came from Google. I think hopefully he referred to it somewhere down there. I think you can find it if you search it. I think he mentioned it somewhere in his article that where he got his idea from. And then actually this is the article. In 2016 it came out. So anything is the free PDF versions out there. Also, I wrote these Medium articles that you can, if you're interested, you can go through, and I explain some of these things through that as well. I was supposed to do this talk about 20 days ago. I think I forgot to let people in my ideas know. So we have to postpone it to now. And there was two other things that I was mentioning. One was decentralized partially observed Markov decision process, which is, again, this has been built to be a decentralized platform, and it can be extremely useful for autonomous cars or robots. And I will try to talk more about that. And the other one was pattern discovery, which I was telling you is about finding the transaction histories and recommending for marketing. So, oh wow, it actually, I reached to the almost the 1 hour. If everything is good with you guys, I will stop here.
Yep. Okay, sounds good, Farshad. Thank you for that presentation. It was great. I'm sure we all are taking something away from it. We do have about 5 minutes left or 4 minutes left. If anyone has any questions, you're more than welcome to send them via the Q&A or the chat. Farshad will be sharing his presentation with us, and then this presentation will also be available on YouTube if you want to go over it again. And then if you would like, Farshad, you can also send us a link so we can make to the articles that you were talking about to make
Absolutely.
sure we can.
I'm gonna send you the link up to all these articles and some other reading material and my presentations by tomorrow.
Yeah, that sounds great. That sounds great.
Absolutely. So thank you very much. Thank you everybody for your time, and I really appreciate that you joined. Hopefully it was useful, and I hope, because I know it's Saturday, you guys have a lot of great things you could do, and thanks.
All right.
I don't see any question. Do you see any?
Yeah, we have one question in the chat from Albert. Using a decentralized model, how can business safeguard their proprietary information? Will competitors not have access to the data?
So, so we think actually the definition of IPs are going to change. Let's actually let me go back. Let's talk about Ethereum. So this group of guys, they work together, spend many hours, they created Ethereum, and they release it to the world. And after that, they don't own it. It doesn't belong to them. The community can decide what to do with it. So, but some of these guys own a big chunk of Ethereum tokens. So the better Ethereum becomes, the value of their tokens are going to go up. So that's how they're going to make money out of this. So now let's say if I build an AI models on a data sets that I have, and now I bring it there, I share it with others, then I'm gonna, so one of the things that we thought about this is this. I don't think I built the best models. I think there are a lot of younger data scientists that they are more talented, they can build better. I can build the first one. I say, hey, if you can build a better one to fit this, just do it by all means. Because we are trying to promote the whole platforms. And if we have stakes in that platform, if you do anything to make that better, that's how I'm going to make money. And you are incentivized to make it better, because you're also going to be incentivized. You're going to make money on that platform. Does it make sense? I don't know if I completely answer your question, Albert.
Mm.
Oh, thank you.
Yes. He says, yes, you are a legend, Farshad. All right. Does anyone have any other questions before we end the webinar for today? And if you do come up or have any questions that do come up later on, Farshad, if you want to make your email available to our attendees via the chat, they can send you the questions.
Or they can send it to me through LinkedIn. Actually, that will be the best because many of my emails I usually don't read them. If
Oh,
I
okay.
don't know, yeah. So LinkedIn will be the best. If you add me there and just send me the message there, I will try to. I usually answer to the questions over there.
Okay. Sounds good. Sounds good. All right. So we're actually at time. So again, thank you so much, Farshad, for sharing with us your presentation and your knowledge on this topic today. It was a pleasure having you for this webinar today, and thank you for work. Hopefully, we can work together in the future with ideas again.
Pleasure is all mine. Thank you very much. Thank you everybody for your time, and have a great rest of night.
All right. Okay.
Thank you. Bye
Thank
bye.
you. Bye bye.